All right, let's get into it. Today, we're going to be tackling a really cool concept that's basically changing how we predict the future. It's all about modeling with probabilistic structures. Just think about trying to predict anything: the stock market, tomorrow's weather, a patient's health. The world is just filled with randomness. But what if? What if you could actually create a blueprint for that uncertainty? A map that doesn't just point to one single destination, but instead shows you an entire landscape of possible outcomes. Well, that's exactly what we're exploring today. So, let's kick things off with the most important question. What in the world is probabilistic modeling? At its core, it's really a way of thinking that totally embraces the unknown instead of trying to ignore it. Okay, so here's the textbook definition, but let's break it down. Probabilistic modeling is all about building these statistical models that, well, they don't give you just one neat answer. Instead, they represent uncertainty using things like random variables and probability distributions. The key idea here is that they're designed to forecast a range of possible futures, and they'll even tell you how likely each one is. This whole approach really has three main jobs. First, it helps us look at all the randomness in real-world data and actually measure it, quantify it. Second, it gives us a much more detailed, nuanced understanding of what might actually happen. And finally, and this is the big one, it lets us make way better, more informed decisions. And that brings us to the why. Why even bother with all this? Well, it's all about finding a smarter way to handle the messy, completely unpredictable nature of real-world uncertainty. The real magic here is in the predictive power. See, by looking at all the different ways things could unfold, all those potential scenarios, and then attaching a probability to each one, we're not just guessing anymore. We're making smarter, more calculated moves based on a deep understanding of what's possible. It's kind of like the difference between flying blind and having a full instrument panel showing you every single variable. Now, to build a really solid model, you gotta have the right parts. First, you have to pick the right probability distributions for whatever problem you're trying to solve. Then, you use your actual data to shape and define those distributions. And third, and this is absolutely crucial, you have to accurately map out how all your variables talk to each other. If you get those three things right, your model becomes incredibly powerful. So, how do we actually visualize all these complex relationships? This gets us into the how of it all, and it involves creating a special kind of map for our data. And that map has a name. It's called a probabilistic graphical model, or PGM for short. The best way to think about it is like a flowchart, but for probability. It's a visual graph that shows you the direct relationships and, this is super important, the conditional dependencies between all the variables. It just makes a tangled web of interactions way easier to understand. These graphs come in two main flavors. First up, you've got Bayesian networks. These use directed graphs, with arrows, to show cause and effect. Pretty straightforward. A causes B. Then, on the other hand, you have Markov random fields. These use undirected graphs, so just lines connecting things, no arrows. They show correlation. So it's more like A and B are related, but it doesn't say one actually causes the other. And, this quote really nails it. PGMs are a flexible framework. They aren't some rigid, one-size-fits-all thing. And it's that flexibility that makes them such an incredibly powerful tool, especially in a field like machine learning where you're just dealing with massive, incredibly complex sets of data. Okay, so this all sounds great in theory, right? But how do you actually build one of these things? Let's walk through the step-by-step blueprint for creating a probabilistic model. The whole process is actually pretty logical. It follows 6 key steps. First, you define your problem. What are you trying to solve? Then you get your data ready. Step 3, you pick the right kind of model. After that, you train the model using all that data. Step 5, you have to validate it. Make sure it's actually accurate. And finally, you tweak it, refine it, and deploy it for use in the real world. And the applications for this stuff are literally everywhere. I mean, this isn't just some academic thought experiment. In finance and healthcare, and of course in machine learning, these models are busy turning all that uncertain data into real, actionable insights. Which brings us to a final thought for you. We've just walked through this whole blueprint for mapping out and modeling uncertainty. So if you had this powerful tool in your hands, what's the first complex, messy, uncertain problem you'd want to solve? Something to think about. Thanks for tuning in.